Okay, hi everybody. Hello, 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 hello. Welcome to the St. Louis Angular Lunch. You're kind of at Oasis Digital, which is technically in that building, but we sponsor and kind of produce this Angular Lunch. Today we have Paul Spear speaking. He is one of our most probably our most guru of gurus in the Angular world. And I'm going to make sure he remembers to plug the evening Angular meetup that Paul plugged the thing you organized, don't forget. But we definitely are great to see a pretty good sized crowd here in spite of rain. I think that in theory there should be like 10 more people here, so that's really not too bad for an awfully rainy day. So Paul, take it away.
All right, thank you. So today I'm going to be talking about pluggable Angular apps. So generally we like to keep the Angular lunch topics on the little more advanced side, and this is definitely an advanced talk, or rather an advanced topic, but I'm going to be kind of giving it an introductory treatment because the content within here you could spend months and months and months learning it, and so this is going to be just a nice introduction to what does this world look like and kind of where are we at in the Angular space when it comes to this kind of topic. And so this is me. I'm Paul Spears. Like Kyle said, I run the STL Angular meetup. When I'm not doing that, working here, I'm a technical lead at Oasis Digital. And I'm also the curriculum maintainer and lead instructor for Angular Bootcamp. So, diving right in, what is a pluggable Angular app? And so I was looking around, doing some research, and what I came up with from all of that was this was the best definition I had found. And this was actually from someone who was asking the question on Stack Overflow as to how do we do this in Angular. I'm going to go ahead and read the definition. It's just a system which allows third-party developers to create or extend the functionality of a primary application through the use of pluggable components without having direct access or knowledge of the primary application's source code or inner workings. Now, I would describe this definition as aspirational. So this is kind of the ultimate answer, like the main goal that we would love to get to. And now it's, to me though, it's a bit constricting. There's slightly less advanced ways to still achieve some of this pluggable functionality. Throughout this space, you'll hear other terms used to describe this, such as this is a plugin architecture or plugin framework for your Angular app. You'll hear people refer to it as simply extensions or just simply plugins. And then you'll also hear folks use the term dynamic components. And I'll talk more about that particular term here in a moment. So for such a system, this idea of, I have some external code that knows nothing about my internal main application code, where would we find use for this? Why do we even care about such a system? As it turns out, some of the most important clients with the biggest projects and budgets are those who likely care most about this kind of problem. So it kind of behooves all of us to know about this kind of problem and where we could slot in to fill this need. So examples of this, you see them here, but we're going to talk about each one briefly. A CMS use case. So WordPress being your kind of classic CMS example, you might have folks who are trying to build out their own for their own internal uses at a company, and they need their end users to be able to go ahead and slightly tweak or define some custom content. And maybe you want to expose some of the data and attributes that your host application has to them and allow them to then render that in particular ways. Or maybe in the most simple case, like you just have a plugin system for your CMS. And so this idea that at runtime, a different user is going to be seeing and creating content that's dynamic, and they're also going to be consuming different plugins that the next user may not. And having both of them be able to do that with the same app is one use case. Another is more generically, plugins in general. So this is actually a screenshot of a plugin that we've made for Jira. This idea that this white section here, not part of the main application, doesn't really know any of the internals of how Jira operates, short of the APIs they intentionally expose to us. And so we're able to extend the functionality of Jira by authoring our own individual Angular application and have it be embedded as part of it. I have embedded systems here in quotes to kind of describe a problem that we came across. We've got a couple of clients that have this notion of, I actually need to ship the server that actually runs the web code on this system. And so they have, think of it like kind of like a kiosk mode, where the server that's actually running the application is housed locally to a device. And they have many, many, many of these distributed across an area. And the only way then to provide an update to that application is through the data that you send to it over the APIs. And so there's this need in that case to be able to dynamically update the functionality of these applications without recompiling the core application. This is kind of a cheat of an example. It's basically just a variant on the plugin system. It's the notion that if you have a team and a project that is so sufficiently large, you might actually come up with a use case where you say, you know what, I would love it if I could have 20 different teams working hard on 20 different facets of this project, and I want them to be able to treat their particular code bases as extensions and plugins to this core architecture without the need to recompile that core system. And so it's basically just another play on the plugin and extension-based idea, but it's another particular use case where plugins and extensions aren't really what we're trying to sell here. It's just that that architecture lends itself towards helping very large systems. Okay, so having distilled all of these kind of use cases, we actually come up with a rather lengthy list of requirements that we have to have in order to fulfill all of these needs. Key ones I want to call out, changes occur without the need to rebuild. This is kind of the recurring theme. Now, again, that actually isn't going to apply to all of these use cases. And we'll talk about some of the tricks that Angular gives us to get some of this dynamism without necessarily worrying about this rebuild issue. Jumping down can be built with standard tooling. So there's this notion that, yeah, whatever we come up with, we don't want every developer having to do some crazy build system that no one else is using and have to troubleshoot a bunch of System.js and Webpack configs all day, every day, just to get their app to run. AOT compatible. And so we'll see why this is on here shortly, but the idea that, yes, Angular is designed to be built in production with that AOT switch on. They intend for you to take advantage of that functionality, but the very way that AOT switch works is going to actually cause us a lot of pain trying to solve this problem. And then we might talk about the rest of these as they come up, but this is the challenge. This is what we're after. All right, so now putting that into context with what we just talked about, we kind of have this matrix now of use cases and the kinds of characteristics that you're after. And kind of for me, the takeaway from doing all this research was it is worth putting together this kind of matrix for your own problems because none of the solutions that we have available are clean-cut answers. You kind of have to begin to understand the nuance and the trade-offs of all of them and then apply that to your collection of needs. And so this is my shot at kind of categorizing which of these types of systems need which of these characteristics. I actually would change, when I made this graphic, I put in here that embedded in large systems don't care about version skew of like Angular. I would actually go back and change this whole column to yes, and I'll talk about that more in a little bit. All right, so the key challenge. What we're trying to do here, we saw the characteristics we'd like, but there's a fundamental key challenge, and that is that Angular applications, if you kind of go down the default path of using the tools as they come in the box, as they're listed in the tutorial, you'll find that they actually prevent this kind of architecture. Fundamental to how they work is that Angular applications, they're compiled and bundled together, and those two processes of compiling and bundling are actually intertwined. And so this notion of I want to be able to dynamically create a piece of content and then have it loaded at runtime, there's actually two barriers that are preventing that, and they're both actually intertwined. So let's go ahead now and take a brief aside to appreciate the fact that, once again, naming is hard. So if you're out on your own looking for practical solutions to this, you're going to have naming conflicts all over the place. And so to start, though, I want to talk about the word dynamic versus this plugin-based pluggable architecture. So you would describe a system that kind of has these characteristics as a plugin architecture or a pluggable Angular app, but you achieve that by creating dynamic components. And so they're not the same term, but they're related. It's the idea that you need to be able to dynamically load your components And that's what gets you this kind of system with these characteristics. So if you go about looking for, well, how do I create dynamic components? You're going to find a whole host of messes. And so the comments in no are ways in which people have tried to describe dynamic components and dynamic templates in the past, and those are not actually what we're talking about. I don't want to say that they're wrong necessarily, because in the generic sense, these describe dynamic things, but for the case of what we're talking about, these actually are not what we're trying to figure out, what we're trying to get our head around. And so in the yes category, depending upon context, we might actually be talking about some combination of any of these. All right, so I said that your Angular applications, they are compiled and bundled together. Now this is a very large departure from what we saw in the AngularJS days. In the AngularJS days, this problem was fairly easy to solve. The way AngularJS operated was the ability to compile your Angular templates shipped in the box with Angular. There was just a readily available API to say, take that template, turn it into an Angular template. And now in Angular 2+, that's gone. That doesn't really exist. And so the way you work when you have an Angular component is you technically don't really have HTML. Technically what you have is this Angular component flavored HTML. So starting in the top left, when you have a component in Angular and you run it through that build system, what you get is a combination of your TypeScript, CSS, and HTML that are all transpiled, compiled together, and boiled down into what's called a component factory. Now, most of your applications, you've never seen or heard of this component factory, but it actually rides within the Angular APIs. It's something that you can use to generate instances of components. In fact, it's what Angular uses. When it comes across a template and it knows that it needs to then go ahead and turn that into a component, it creates a component factory and it grabs a component instance out of it. Well, whenever you're using an AOT build, what you get is it will then make these component factories. It'll make component factories for all your other components. It'll bundle those all together and make a module factory. Those module factories, those are then all rounded up together, and those are actually what live inside your bundled application payload. So that way, as Angular operates at runtime, processing your modules, whether they be lazy loaded with a router, for example, or just part of the runtime execution of getting your modules onto the page, these module factories are executed. Their internal component factories are also executed to then generate the instances of the components that render on your screen. So by default, this is what you get. And so what we need to do to achieve any kind of pluggable architecture is we need to find a way to break this up on a couple of axes. We need to find a way to say, all right, let's take our components and our modules, and we need to find a way so that I can build this independent of the rest of my application and separate that content out from the rest of my bundle. Furthermore, I need to be able to find a way to then load that content at the point of use, at the time of use, based upon some sort of arbitrary logic. So that's the actual fundamental thing that we have to be able to achieve to do this. All right. And within Angular, there's a couple of different tools and techniques. Now, we're not actually going to see too many of the details, again, because each one of these is a very long, multi-step process to get any of them to work. But here are the fundamental tools that we have today to achieve this. So we're going to talk about each in depth, but the basic idea is that because we have these two axes, one of splitting apart the code base and the other of loading it on demand, not all of these are strictly linear in terms of, oh, now you get a little bit more functionality. It's really a combinational effect of you put the right combination of these tools together to achieve what we're trying to do. All right, so looking at the first one, createComponent. Now this is, at the end of the day, this is actually the underlying piece of API that all of these techniques are going to use. You can use it on its own, but all of them are going to fall back and at some point in time call createComponent. This is an API provided by Angular to say, given a reference to a particular portion of my template and given a factory that knows how to create a component, create me a component and render it in that space. So nearly every Angular modal dialog that you've ever seen, at the end of the day, this is what it's calling internally. It's saying, if you hand me a reference to a location, then I will go ahead and use my internally known component factories to dynamically add that component to the page. And so at the end of the day, yes, this doesn't help at all with splitting up our bundling, but it does add our first small touch of dynamism. It's the thing that says, at runtime, dynamically choose, based upon some logic, to show a thing. Now, to use this, you have to do all kinds of things with still dealing with the fact that all your components are bundled. So this isn't a full solution, but for many kinds of problems, this might actually solve the problem you're looking for. Now here's a graphical way in which this works, and I'm spending a little more time on this one because, again, at the end of the day, this is the underlying mechanism that all these solutions use. And so basic, big picture ideas. If you have a reference to whatever dynamic component you might have, such as like my modal component, if you have a class reference to that, you can then pop that into an Angular service called the component factory resolver, and that will then go and actually find the corresponding factory that knows how to generate component instances out of it, and you can then take that coupled with a feature view. So this is just a template reference that you can create in Angular. You put those two together, call createComponent, then you end up with your fully rendered Angular component appearing on the screen. So this is the thing that before you do any other research, you've got to fully understand and fight through this. But again, it just takes you that first step. So up next is the System.js ng module loader. So this is actually tackling that other axis. This notion that, okay, if you have found a way to split up your bundles, how would you go about loading them into your application at runtime? And as it turns out, this is actually packaged with Angular. This is what the router uses behind the scene to go out and fetch your lazy loaded modules. And we can actually tap into that in a similar way. So that subtitle there, that this is technically just a module loader, is true. This actually doesn't necessarily have to be used for this notion of dynamic components. But you can, if you couple that with a module compiler, use that to then take a module that lives somewhere else, at some random URL or locally to that server, fetch that module, compile it, and then get the component factories out of it. Some quick notes on that. So there's some nastiness about this. One is that it actually requires System.js be on your app at runtime. Another is that it can actually be kind of hard to work with a CLI. Depending upon how you've split and bundled and actually done the build part, you might actually not be able to use the CLI for sufficiently complex versions of your application, especially with AOT in particular. So this runs afoul whenever you try to AOT compile your application a lot of times. All right, the next one is the compile module and all components API. And so this one's kind of interesting. So this is the only code that we're going to show. And this shows an example where we're actually going to take some generated HTML with an Angular binding in it, and we're going to turn that into a component on the fly. So it starts off real simple with a template. Right here we have our binding. Now I said, Angular doesn't have such a thing that lets you compile just templates, and that's true. So what we do is we take that template, and instead we're going to turn it into a component. We're going to add it to an Angular component. And so what you're seeing there on line 9 is actually that component annotation that you'd normally put @component in front of. That's just syntactic sugar for a function at the end of the day. And so here, this is demonstrating a hack where you can call that component function directly with your metadata, and then you finish the execution of it by passing it that class. So this would be where you put your constructor, do your dependency injection, etc. And so this creates a component in memory. And then on line 10, we create a module in memory. And with that module, we register our component. Because whatever module is running the component that this lives in, that has already been precompiled and built. So we can't just add this component to our pre-existing, pre-built, now running module. And all components must be declared somewhere. So we have to make a module, and we stick this component in it. Then on line 12, we're using this thing. It's not actually defined. Actually, it is right here. This compiler, and there be dragons. I'll talk a little bit about them briefly. But we can actually use the Angular compiler to compile module and all components async. And so I actually dropped the async here. So there's the full thing. And what that will do is that will take a definition of a module, and it will turn that into an actual module factory, which is a promise because it's an async process. It then gives you those factories, and then you're able to reference them to call createComponent. So like I said, the createComponent underlying thing to all of this is kind of a one-shot view of kind of your most basic, fully dynamic thing. So all those other things, those were steps and pieces to get you there, and you can hack those together in different ways. This is the first time we're seeing, based upon some code, based upon some HTML, in this case it was statically defined. This could have just been the result of calling subscribe on an observable or then on a promise to get this data. But given that data, create a component out of it, create a module out of it, use Angular's compiler to compile it into a module, and then extract out the pieces to create our component, and then we're attaching it to a particular view container. And you can see @viewChild is the easiest way to get a hold of one of those. So, yay, we're done. We've achieved what we've set out to do. Not quite. That compiler there, that is the Angular just-in-time compiler. So now that we've gone through all the trouble of working really hard to make sure our app AOT compiles, we've now added the bundle size of the just-in-time compiler to our application, and now we're bundling, and now we're actually generating components that are just-in-time compiled, which have less than desired performance characteristics compared to their AOT equivalents. But if you're running on an internal application, you're not doing this too many times, and your customer is your organization, this might be an acceptable approach. It's definitely the most ergonomic approach. For the developers, they hardly have to care. It's really the runtime production characteristics that you need to make really sure fit your use case. And then there's custom builders. So this approach is actually built upon a couple of technologies that have recently landed in the Angular CLI. Angular CLI has now been extended to allow you to define some custom build properties about how the underlying Webpack performs. It actually lets you extend that build process. Now, the process that works to do this is ridiculously complex. There are like 20+ steps needed to make this work. But once you've gotten through all of that, you actually end up with an experience for your team that's simply ng-build, ng-start, etc. But you have to do a whole lot of upfront work to get the configuration in place. But the basic idea is emerging from these new features, we can actually achieve all of this by modifying our Webpack build to create a build that knows how to split apart chunks of our code, and then you use that same build to build the pieces of your plugin. So, for example, if you're looking at third-party plugins being authored, what you'd need to do is you'd need to inform those potential authors that in order for your plugin to work in our system, you have to use this build configuration in order for it to be compatible. Okay. Fortunately, though, because this extends Webpack through the CLI, you don't have to eject. You're still using the CLI to do all of your work. It also benefits from the ability to take advantage of another feature that's been added to the CLI of accessing Webpack's underlying externals feature, which is a way of saying, yeah, I know that when I compile this, I expect this external library to be present at runtime. And so, again, when you bake that into the config for your project, you can build your host app and all of your plugins being able to take advantage of the known fact that those APIs, those libraries are going to be available at runtime. That way, when you bundle them independently, you're not duplicating that library code, adding it every time you add a new plugin. Now, this is the whole thing. It splits up the bundling because it has, you bundle each module using that same custom config, and it's fully dynamic. It allows you to create a service using that system loader that will then load that module, but that module has already been compiled, so you don't need the compiler. The key hitch to all of this, like the one big hitch, is that the compiled components must be compiled against the same exact config of your application in order to work. Now, I'm going to actually go back a slide or two real quick. No, I'm not. I'll show you the link for this in here in a moment. Oh, nope, it's right down here. This link right here, I'll give you the link to my slides, which will contain this link. If you want to know about all 20 of those steps, like this is it. This is the tutorial to achieve this right here. Yeah, quick question. Yeah, one second.
So based on one of the last things you said was that every compiled bundle needs to have the exact same config.
Mm-hmm.
That means that external plugins that you'd like to build for it would have to be aware of the consuming configuration, right?
The build configuration, yes. And so you would have to set up a contract, so to speak, and then like a tutorial to say, here's how you build plugins for this system. So it's not really about how the app works as it is so much of you must build in this way to play, basically. So it's not so much what the application does as it is how the application is built.
Okay, and I'm a little fuzzy on how it actually consume those external ones. You're probably going to get to that, but
yeah. So how it consumes those is that that system.js ng module loader that I referred to earlier. There's similar APIs that Angular exposes to you to be able to go ahead and use like system.js to fetch the bundle. And so what you can do is there would be a lot of like infrastructure work to kind of like set up all the ergonomics for this. And again, that's why it's 20 steps. But the basic idea is that you could have a database, for example, that contains an entry for one entry for a plugin. And one of the fields in that database entry would be like URL location of the bundle. And then at runtime, your application would would fetch that entry, see that URL, throw it into the system loader, and then it will then fetch that bundle from that URL. And then because that's already precompiled, it could then access the factories within it. Those factories then go on to call, you use those to call createComponent. Again, that's still the underlying thing here. But the fact is the hard part is being able to know that that remotely bundled module is actually compatible with your app. And so here we are able to know that because we're sharing that same config. All right, so looking at all these approaches, we had a matrix earlier for, here are my different use cases, here are the characteristics I want, and now we're stacking up the different approaches against those same characteristics. And like I just mentioned, custom builders, that's kind of your go-to for having all of the answers. It's called getting yes across the board until you get to dev ergonomics. That 20-step process is brutal, and it will take a lot of studying and understanding and work to get that all figured out. And then even for the other ones, most of those are in the meh category because they work, but all of them are kind of fraught with peril in terms of like, oh, okay, great, I've got this component now, but this component wants to access some dependency injection of a thing that isn't in your host application, for example. And then what do? How do you error handle for that? How do you not have your application fall over when a dynamic thing is loaded? At the end of the day, all of these are still very, very fragile approaches. Now, all of them also have this problem of version skew over here that we still have to address. And we'll talk about that in just another minute. Now, hopefully, Ivy will save us all. So a large part of what Angular has been like busy doing for so long is they've been hard at work at realizing, hey, this is a big problem, we need to solve it. And we got a fundamental challenge of the way we compile our components takes that component and takes part of its data and then goes and attaches it directly to the application in a way that makes them very difficult to separate out. And so how do we go about doing that? Well, one of the goals of Ivy is that it will actually change entirely how it compiles your components. And so each component now is able to be compiled independent of a module or the rest of the application. It does not need to take those into consideration anymore. The way they compile them, the way they've changed their renderer, is able to attach all the necessary bits it needs to know how to render that particular component to the compiled output, so that at runtime you don't need to cross-link that with some metadata in your application and create a factory that knows how to bring them together to create an instance. Your compiled output is a ready-to-go piece of code that can be used to turn on and create that component. All right, so again, this is kind of highlight the fact that it was both the AOT compilation, that idea that I want to bundle and compile ahead of time, and the fact that we're bundling that output together that was the problem. Ivy is looking to break both of those up with their new compiler. Now, where does that get us in terms of, okay, great, how do I use it today? Well, you can actually tap into Ivy. There's an experimental opt-in in the latest version of the CLI that you can start using Ivy today in terms of practical applications of making a pluggable system of it. Everyone's like, I'll let you know when it's released. I'll follow up with a blog post once it's actually out. APIs are still in flux, in development. Anything you build today will fall over tomorrow. And so people are waiting a little bit longer for Ivy to be the rest of the way there to actually sit down and crank out the machinery. But I would not be surprised if it's like if we don't see an alpha library, an alpha version of a library for pluggable architecture within 4 to 6 months of Ivy being fully released. So fortunately, much like with when is Ivy going to be out, the answer to how Ivy is going to save us is, well, we got to wait and see. However, I'd like to stop for a second and talk about a non-Angular solution to this problem. And we had this version skew column, where for all of those approaches, we had a really big problem. And that is, even in the best case scenario, you were kind of like, it sounded like you were rightly incredulous to the fact that you mean the third-party person has to use a particular kind of config to build their plugin. Well, it actually gets worse than that. They also have to use the exact same version of Angular as your host application, and of any Angular components you might be using in yours. And you end up in this situation where every architectural decision that you make in the host application, you'll need to make those same decisions for all of these approaches in the dynamic component that you're trying to build. So this is also particularly problematic if you're looking at doing something like making third-party plugins a possibility. Because then you're in a spot where you have your host application, a critical security bug comes out, and you need to upgrade to the newest version of Angular, and maybe there's a breaking change between 8 and 9 where that security fix was introduced. Well, now you need to go back, and if there was any internal change to how Angular compiles modules and compiles components, you're now going to have to break every plugin that's on V8 of Angular. So that's a good way to say, you know what, we're never updating Angular ever again. And so that's the kind of problem that you're looking at if your mental model of this problem is, hey, I know, let's use Angular to build a plugin system. So beyond using Angular, I'm thinking, hey, let's try a more forward-thinking approach. Let's talk about web components. So web components, it's the idea that you can actually have your third-party producers go ahead and make whatever kind of component that they want. It will use whatever kind of language, whatever kind of framework to produce it, and then you have your application load that native web component. Sure, there are still rough edges to figure out in this space, such as how do we deduplicate libraries, for example. If your web component needs to use jQuery and your application uses jQuery, now you've got 2 versions of jQuery. But similarly, like that externals idea in Webpack, there are ways that you can set up a contract with your third-party plugin authors to say, hey, expect these scripts to be available at runtime. Don't load them. You have to come up with your own build tool chain that'll run them at dev time, but then exclude them at prod time. There are solutions to that problem, but more importantly, web components is a way that the only target that you have to hit is what browsers do you want your plugin to support, rather than what kind of version of Angular does the host application have installed today. So that's it. That is the talk. Again, the slides here, they have on the next page all of the URLs, and those URLs are all great. Big shout out to the Angular in-depth blog and the folks at AGGrid. Those guys are light years ahead of everyone in the space of dynamic component understanding. So big shout out to them. Most of my content came from them. Again, I've got the slides here, or the URLs for where I got all this from them. And there's the URL for the slides, so you can get access to those. So any questions?
Were you able to use web components in this way, or did you have a prototype or anything?
No, but if you want to see an example of that, Corey gave a great talk on web components a couple months ago now.
I just meant like with the pluggable interaction.
Well, almost by definition, they are pluggable. It's the idea that if you can fetch the URL, the JavaScript that has that plugin, and you get that running on your page, it then registers that component for use. And so it's completely agnostic of whether you're running Angular, React, Vue, Svelte, whatever. You go ahead and you get that onto the page, and then you're able to then drop in a reference to that component. And so you might have to establish some sort of contract about upfront, okay, which components am I going to be able to have available to me. Once you have that, though, like you have a registry of that, once you have that, you're good to go.
Okay, so I have a question. Like, given the kind of compelling advantage, kind of the web component thing, and that version skew problem just seems like it'd just be completely horrible. I can't imagine any project that spans more than a handful of people where you wouldn't just be stuck, like you just stop evolving with Angular forever if you hit that problem. Like, is there any reason not to just like discard all the other approaches and just say the right answer for pluggability in a web app is web components in 2019? Like, is there any case where that's not the right answer in 2019?
Yeah, so going back to the compatibility table here, the reason that I had originally listed these as like, no, these don't have a concern with version skew, is that I could actually make an argument for in the case where the reason that you're doing this is because you have embedded systems, or the reason that you're doing this is because you have a very large team. The logistics of upgrading your versions together only extends up to a problem of like what your team can solve. And so if your team can migrate their extensions and plugins and core library together, then yeah, this becomes an easier to mitigate problem. Now that doesn't mean it's not a problem, but it becomes easier to mitigate. And so in that case, not taking on yet another language, framework, technology paradigm, it might be useful in that case to be able to say, yeah, let's just stick with Angular for all of it, deal with the version skew, and just fight through that, because it's going to be easier to fight that problem than onboarding multiple teams, throwing random, probably poorly written web components at us. All right, any other questions? Okay. All right, well, thanks everyone.